Hi, welcome to the Ben and Chris show, where we're going to be teaching you Python. And we have been teaching you Python every Thursday evening. I'm Chris, and this is Ben.
Ben. Yeah.
So last week we promised we were going to go through loops. We never actually got to loops. So this week we are officially going loopy. But Ben's got something he wants to say first.
Yeah. So I think, firstly, I think it's pretty good actually that we ran over, because I think loops is one of these things where it deserves its own kind of episode. It's really fundamental part of Python. Before we start though, I want to talk about something we didn't cover I nearly said yesterday, last week.
All blends into one this time of year, doesn't it?
Yeah. But something last week we didn't talk about was this thing called elif, which stands for else if. And that's what I'll firstly talk about before we actually get into loops. So hopefully only spend about 5 minutes or so actually on that part.
And as always, if you have any questions at all, throw them into the YouTube chat and we'll do our very best to answer them.
Yeah. I think if you want any questions at all, like if something's a bit confusing in the code or whatever, feel free to comment out. I quite like that back and forth. But anyway, I'll get into.
Makes us feel like proper YouTubers.
Yeah, interaction. Yeah, but yeah, I'll get on to else if. So what we've looked at so far, or what we looked at last week, was we looked at ifs, right? So if we have a variable called, I don't know, money, and set this to 50, and we say if money is more than I don't know, 30, then you can buy something. I should replace something with something of value that is £30. But yeah,
something more than 30 quid. Yeah.
Yeah. Otherwise, this kind of implies that this is a shop where everything's £30.
That'd be the Covent Garden version of the pound shop, right?
Yeah.
The £30 shop.
The £30 shop. Yeah. But yeah, so if we run this, you can see we've got £50, and it'll say, yeah, you can buy something. If we change this to £10, right, then we don't get anything. We can't buy anything. One thing I want to talk about now is we've talked about if, and we've also talked about else, right? So this we can say, get out my shop or something. So now it'll say get out my shop because it's running this one instead of that. So else is almost like otherwise. The one thing we didn't look at was elif, right? And elif is this, right? Elif is almost like a kind of like an if statement, and I'll get into what that means. But say, for example, I've got an example here where, remember last week we talked about grades, and we said, if the grade is more than a certain amount, then say pass, otherwise fail. So say we've got a grade of 80, we had something like this where we do if grade is more than I don't know, 40. Yeah.
I remember we had passing students at 30% last week.
Yeah. We can say pass, right? Or we could say more than or equal to, and we had an else, right? And we said otherwise print fail. So if we have a grade of 80 here, then what it's going to say is it's going to say pass. But if we change this to 10, then we get fail. But wouldn't it be good if we had some kind of classification here? Like if we said grade is more than 90, then print out wow, amazing, or something. And then if could we do something like if grade is more than equal to 50, then print out brilliant, and so forth. And can we do this many times? So if we do 30, we can say it's okay. So if we put in something like 90 here or 95, what we're going to get is we're going to get wow, amazing, brilliant, it's okay. But wouldn't it be good if we could choose one of these?
Which would be really confusing feedback to receive, wouldn't it? Brilliant. Yeah.
So yeah, if we were making this software for a grading system, it would be pretty useless because it spits out everything. Like if you get 90, it's going to trigger this one because all of these...
we talked about this from conditions that they are all true. If you go through that, 95 is more than 50, 95 is more than 30.
Yeah, so it's as you can see, it's going to run all of these, right?
30 is not okay. That's still well, but change it to 40. It's upsetting the grader in me.
Okay. So and we could have an else at the end of this and say fail at the end of that or whatever. But yeah, all of these, what we're doing is we're saying that we're asking, is it more than 40? Is it more than 50? Is it more than 90? And in all cases, it's true. So it's going to print out this. Now, wouldn't it be good if we could just print out one of these? Well, we can, because if we use elif, which stands for, if you've used any other programming languages before, it's else if. It looks like that. So elif is very similar to an if, but in this case, it treats all of these as one thing. So if we run this, you can see we just get wow amazing, because what happens, see, what we did before was we ran this and it printed out wow amazing, and then it went to here and it went, oh, okay, cool, I'll run this. But in this case, because we've got an elif, it will see this one and run it and just ignore these because it's already run this one.
The way I like to think about this is think of these statements as being nested within each other, which isn't quite the way that Python does it, but it's an easy way to remember it. So it's going to the first one and saying, is this true? And if it's true, it breaks out of that program and just prints that statement. If it isn't, it's like it goes, right, if this isn't true, try this. And it's always looking at the one above. And then if it says, if that one isn't true, try this. So it kind of keeps going through. So it's almost doing like a best fit process.
Yeah, exactly. And as you said, right, it's like this. If you put them all in another, I mean, this looks awful, but it works kind of the same way, right? Or actually, I might ignore it. But if you did this in reverse, if you did this like 40, 50, and 90, then it would, and we swap these around, so this would be wow amazing and so forth. Then we'd get something, I think, like that.
So one thing you can do with elif, if you just want to delete that for a second, Ben.
Yeah, there we go.
So we could actually just clear that entirely.
Okay, yeah.
And I sometimes use this for if I want to create a program to, say, classify a plant, right? You could have two sets of else. So if we do user input number of leaves, and user input color of flowers.
Okay.
Actually, no. That would make it complicated. No. Actually, yeah. Just put color of flowers. That's right.
Okay. Yep.
So, actually, change the number of leaves to number of petals because that's upsetting me now.
Okay. All right.
So what we could do is have, say, two if statements. An if and an elif. If number of petals is less than 5, and an elif that said if number of petals is equal to or greater than 5. Right, what we could now do is essentially put functions within those. So we can start then, so if in number of petals, if we put a number of another if, that says if color of flowers is equal to red, then print you are a rose. You are a poppy. There we are.
Okay, yeah.
and if number of elif color of flowers equals yellow, you are a daisy. And then we could continue doing this, but in number of petals, just say you are a rose. And let's assume that there is only one flower in the world that has more than 5 petals. Now, if we actually run this program, it will give us a choice. So let's say if we put this has 3 petals, and those are yellow, you are a daisy. So we can very quickly kind of, if we want to create a classification system, and hopefully this is clear how this works at this point, you could build up actually a really quite complicated sorting structure. I've actually used this in a previous kind of research project to do. I created a behavior classification system. I was trying to analyze some crowd behaviors. So actually, essentially, what was inside what was a relatively complicated piece of software was a bunch of ifs and elifs. That when the functions were, when the behavior was being categorized, it was spitting out, well, this is what this behavior means. This is what is going on here. And again, I don't know if there's any life scientists in the call. Steve's usually about, but you could use something like this to create something slightly more complex. So we speaking of Steve's actually in the chat. Is there a need for brackets and if statements in Python? And if not, is it easier to get lost when reading the code? So, this is for me. This is the killer of Python.
Yeah, it's. I think it really depends on what programming language you're used to. I'd say. I don't know if you'd agree with that.
Yeah. Now I come from C. Most of my programming these days is in C#, and I find those brackets really useful. But at the same time, I think 99% of my coding errors, when I have them, are due to a misplaced bracket.
Yeah.
And most Python editors now, Ben can probably just highlight over them. They'll actually give you these lines in the showing where the indent is.
Yeah, so here, for example, you see that this line's here, and then there's like a line here. If you can see that, I'm not sure if it will come through on the stream.
Yeah, it's quite faint, but it does show how those connections work. But I think with Python, I'm not sure if Ben will agree with this. It's really important to, I think, break things out into, and we'll cover functions in won't be an episode, probably the episode after that. But it's really useful to break things out into small abstracted functions because they're so much easier to understand and easier to debug and easy to read. One of my big Python programs, one of the ones I used to run on a high performance computer, supercomputer, it had a single block of code that was about 800, 900 lines long that wasn't broken out, that called functions but wasn't broken out into functions. And that was a nightmare to debug because you had to make sure you had the right indent, and some of them were 14, 15 indents deep. It can be tricky, but let's say most visual debuggers, most visual editors will give you those kind of lines so you can see where they are. Yeah,
I'd agree. I mean, the editors, putting something in an editor is really useful. Even for example, here, this is just an online editor, right? But you can do things like code folding. So you see these little icons that appear. You can click these and hide certain parts of the code if you don't want to see them. And yet, splitting things out to functions is, and we haven't touched functions, and we're going to come on to it. So if that makes no sense, don't worry.
No.
But splitting things out into functions is crucial to writing. I'd say writing good code, because code isn't just about efficiency; it's also about making it readable, not just for you, but for other programmers. So and just for the sake of this is just one if inside another, but it's not like infrequent to see an if here and then another if and then another if. So if you can split this out into a separate function, then that's a hell of a lot easier to understand.
And when we do some statistics stuff, we'll quite often use things like recursive functions. and they can be their own special kind of nightmare to debug. But yeah, keeping things really readable, honestly, it's the best way to avoid pulling your hair out, because I mean, me and Ben, we've both worked on a project with another developer, and I think over time, because we've worked together so often, we have very similar coding styles. We can recognize each other's codes quite well now. We have had times where we've worked with another developer and gone, what is going on here? This is completely unreadable. It slows down the entire project. And yeah, it just makes things a lot more difficult. So following some basic kind of, and what that's is actually one of the nice things about Python, that it forces you to indent properly, because that's how Python works. And there's nothing as a developer that will make you curse somebody's name to the stars than poor indentation or braces in the wrong place.
Yeah, it's one of these things where if I can have really quite a lot of respect for somebody as a developer, but then I find out they don't indent their code, and I just go, oh god, I have no respect for you now. So yeah, it's good that Python forces you to do it this way, because in things like C, when we have the option of using brackets, so this is Python, but something like C forces you to use brackets for things like this. To me, this is really readable, but people can write code that starts to look like this. It's just awful. I think having Python force you to do this kind of stuff, it's a really good thing. It's a really good thing for people learning how to code as well, because you get into the best kind of practice there and then.
It's one of the things that makes Python good as a first language. But the fact that it does so many things that are different, like say the fact that if statements aren't in brackets, for example, can be confusing. But like I say, that once you kind of learn, get into a language, once you learn the basic syntax, the rest of it just comes along. Should we do loops?
Yeah. So yes, I just wanted to touch on LF, but the next thing is loops. So you might hear us call these loops or iteration. Iteration's the kind of formal name of loops, really. And there's different types of iteration. There is something called count controlled iteration, right? Which is sometimes called a for loop, and condition controlled iteration, and this is a while loop. And for people who know already what Python is, there is a kind of third loop, which is the for loop, which is iteration through a collection, right? But we're not going to touch on this because that's for later. That's like 3 or 4 episodes in. So we're just going to look at these two. So count controlled iteration. I guess I'll start with what a loop is, what iteration is. It's essentially just repeating one bit of code or some block of code many times. So there's 2 ways of doing that. There's count controlled iteration, where essentially you're repeating the same thing a certain number of times. So one example of this is the only one I can think of is if you have a digital microwave, and I'm always I don't know why, but I always go to the kitchen in my mind. I think of recipes, microwaves, ovens.
I know the example I usually use, but I'll let you do yours first.
Yeah. So at the end of a digital microwave, when it bings, it sometimes in certain models it goes beep, 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 3 times. That's essentially repeating one beep 3 times. It's doing a beep a certain amount of times, and maybe Chris has a better analogy than a microwave.
The one I use is right. Say you were doing a task, like, and I've picked up my guitar because it's hung up behind me, and Ben said, "Strum 4 times." Well, I go right. Now that's count controlled iteration. I've been given been given something to do. I'm going to perform a task, and I'm going to do that 4 times. Okay. Whereas condition controlled iteration would be Ben saying, "Strum until I tell you to stop." So I'm going to keep going
Yeah.
ad infinitum, until eventually Ben will tell me to stop.
Stop. There you go.
And that instead is a condition controlled iteration. So I'm still doing, essentially on both times, I'm doing the same task, but one time I'm kind of following a structure 1, 2, 3, 4, and the other time I'm just going to keep doing it until I'm told to stop.
Yeah.
So that's the way I tend to think of it. It's one is almost you're giving the one the loop, the iteration kind of controls itself. You give it a command, you say, right, you're going to do this 4 times, and it monitors internally how many times it's done it, and it stops appropriately. Or you say you will continue doing this until something changes. So we'll often say, right, for example, Ben, while you are hungry, search for food. Right? And again, it's we use food analogies all the time because it kind of affects everybody, right?
Mm.
But think you do this kind of, you know, while you're hungry, search for food. You'll go out, you'll keep hunting for food until you've got food. Then that condition has been met. It is now true. You stop that iteration. You stop that task.
Yeah. Another example of condition controlled iteration. I think the best way of thinking about these loops is making up these analogies in your head. If you can think of your own analogy, then do it. You know, it's if maybe these analogies don't work so great on you, but think up maybe how you perceive a for loop or a while loop. Another analogy is when you get a phone call, that phone is going to keep ringing until you open it up and press, end call, or take the call. So essentially, you'd have a while loop that says while call is unanswered, play ringtone. But you, as Chris said, you can apply these kind of concepts, similar to an if. We can take an if conceptually and apply it to all kinds of things, our processes in life. And this is computational thinking, right? We could say if kettle equals boiled, then pour kettle. But a while loop, we can do the same thing. We can say, while hungry, search for food. While kettle is not boiled, then keep boiling. So and for loops, we can do the same thing as well. So you can take these ideas and use them conceptually to describe a bunch of different things. And this is why they're so useful, because we come across iteration everywhere in our daily lives. For example, if you want to make 50 cookies, again, I'm going back to the kitchen, right? If you want to make 50 cookies, you don't follow the recipe. You don't have a recipe with literally on the paper 50 times the recipe, right? You don't have a 50-page manual for 50 cookies. You don't have a single page for each cookie, because you're doing the same thing. You're repeating the same thing. So what you do is you make one cookie and then you repeat the same process that you already did. So that's kind of like count controlled iteration. We're making, instead of making 50 individual cookies, looking through, we make a cookie, then we tear off page 1 and we go to page 2 and go, oh great, let's follow this one, and keep doing that until you get to the 50th page. No, we just use one single piece of paper and we go through that. We follow that recipe 1 time, twice, 3, and so forth.
The easiest one to think about is often walking, right? So walking is a repetitive cycle. Your left leg, right leg, and you can continue. And you will either do that for a number of steps, or you will do that until you've reached somewhere. But yeah, we use loops all the time, and we've been programming. Conditions kind of set rules for our code. They kind of create this logic that our code will follow. But loops open up a whole host of options towards making our code more useful. We can do things like, for example, reading a massive data set. We can loop through each cell in that data set. We can for example, if we're classifying a whole bunch of plants using that really simple program that we wrote earlier, we could loop through we could feed in some data and it could process all of that. If we've done a few times where, in fact, let's do this example. It's one we've done before, where we have a yearly expenditure.
Okay.
So if we have two input fields,
Yep.
and we call this first one income, and we make that variable of income.
Okay. Yeah.
And we have another one that is expenses. And let's have another variable which will be savings.
Okay.
Now, if we want to calculate that, what we could have done, which you did previously, is do savings equals income minus expenses. And if we wanted to do that multiple times, we could do that plus equals. So we could add to that saving pot each month.
Yep.
And the way that we would end up doing this is, in fact, just cut and paste that whole line.
Yep.
And say we want to do this for 12 weeks, we'd have to bang it through like that.
Yeah. So. Yeah.
So, and that will give us 12 months of income and expenses. So if we run that program and fill it out, so our income is 200 and our expenses are 100. And we've got savings as an input. Just have savings as an empty variable.
Okay. Oh yeah, it's not printing out or anything. Of course. Yeah, here we go. So
just remove savings as an input field. Sorry.
Okay, yeah. So I'll set this to 0.
Yeah.
And then I assume we do something like savings
after one month.
Yeah. We'll just put 1, and then plus str of savings. What we're doing is we're saying savings of the first month is, and then we're str, if you remember, we're taking a number, which is this, and we're converting it to a string, a bit of text. So if we copy this and essentially do this many times, God, this is going to be awful. I should have really done this right. I should have done it actually.
But I mean, you point out the problem with doing it this way, right? Because every single line, you're having to go through and manually add.
Yeah.
Change that, and again, if we were to do this for 12 months, or let's say 3 years, poor old Ben is going to have to type this out a lot of times. But let's just stop there. Let's stop there and run that and show how that works.
Okay, so 200 expenses is 100. Yeah.
And our savings after 6 months is £600.
Mm.
But we can do this with a loop. So if we add another input field called number of months.
Okay.
And now we can do this in a loop.
And yeah, let's do that. And then
we'd have to, let's just show how it works. So to put the I in the print statement.
Okay. So this is going to be plus str of I plus.
And don't worry if you're not understanding this right now. We'll explain what's going on in a second.
So if we run this and we have an income of, what was it, 200?
200 and 100. And let's run it for 6 months.
Yep.
And again, so we get £600. So we can see that this would work in exactly the same. But the power of this is if we put 200 and 100, and now we're going to put 700 months.
That's, yeah.
Now, just imagine how long it would have taken poor Ben if he'd had to cut and paste that line of code 700 times. But the big advantage, which he can do, Ben, while coding, continue to code until told to stop. But you can absolutely do that. You can just cut and paste that line 700 times. But if you want to vary that, it would be just as quick for us to now put 7,000, 7 million times, and the code would run exactly the same. Now, do you want to talk through what each line of that is actually doing, Ben? And it might be worth just moving the center bar across a little bit so that print statement's on one line.
Okay, so yeah, let's break this down. This first one is probably the most important thing here, because we can kind of understand what this is doing, even if this is a bit weird. We kind of understand what this is because it's what we did before. This is the important one, right? So what this is, we talked about, what was it? All up here we've got count controlled iteration, and I said for loop. That's what this is. This is count controlled iteration in Python. So if I show you a very basic example of for loop, right? So if we have for I in range 5 and we just print hello, right? What this is going to do is hello 5 times. So what's happening here is it's running from, in this case, 1 or 0 to 5, right? And it's running this line of code this many times. So you can put any number in here. You can put 10 and we get it 10 times. We could put it, 1 time and we just get it once. So this thing here controls how many times this thing is ran. And we don't just have to have one line of code here. We could put 2. We could put hello there, right?
Again, the important thing being here that's indented, so that is all part of the loop.
Yeah. So as with the ifs, right? Just make sure that you've got a space here, because this space, this indentation, this is telling Python that this stuff here, all these things with the indentation, is part of this loop. Actually, part of this loop here. So if we run this 5 times, we get this. We get hello there, hello there, hello there, and so forth. So this, we understand what this is.
You have an objection to putting hello world, don't you? You've been told off for that before.
There you go. I'll sort it. There we go. So now we get hello world, hello world. So it's running this stuff, which is indented. It's running it 5 times. So this stuff, this controls how many times all of this is ran. And we don't just have to have 10 here. We could put in, we could call number of iterations. That's a very long name for a variable, but we could put a variable in here, right? Now, if we put 10 here, so we understand that this stuff is being ran 10 times, and we understand that this range 10, don't worry about what range means, but essentially what this is saying is run up until 10, right? This thing controls the amount of times it runs. Now, the next thing you might wonder is, what is I? And this is probably the thing that confuses most people about for loops. So this stuff is quite easy to understand. It's just running this stuff 10, in this case 10 times. But this, I think people get quite confused about what this is. This is called it's called like the iteration variable, or I'm not sure exactly what the name is for it, but it's the variable for which is incremented over time. So this doesn't have to be I. We could put anything we want. We could call it hello. We could call it
iterator,
for example. So this is just a variable. That's all this is, right?
So just to show that, I mean, if you put that back to I,
yep.
And instead of printing hello, just make it print I.
Yeah. So as I said, this is a variable, right? So what happens if we print I? What's going to happen is, as you can see, it's printing, in this case, 0 to 9. Now, it might be confusing to you why it starts at 0. That's just the nuance of programming. Most programming languages start at 0 and kind of go up to 10. It's always
being 0 indexed.
Yeah. So this is really useful for when we get onto it, arrays and so forth, and lists. And we're not going to talk about this today or tomorrow. Sorry, not tomorrow. Next week or the week after, and so forth. It's probably going to be a couple of lessons in before we actually talk about what lists are. But what this is doing, right, is this is just printing the variable. Last time we're just printing out hello. We're just doing this 10 times. But here we're actually printing out what the value of this variable is at each iteration, at each step. So, we could, like I said, we could call this iterate. We could call it hello. For the sake of this, let's just call it hello. Right? So now we've made a variable called hello, and we're going to print out the value of that variable, hello, at each iteration, right? And what's happened is it does exactly the same thing, zero to, because that's all it's doing. And this is really useful. You can see how, we might be able to write a countdown here. So if we did 10 minus hello, then we get 10 all the way down to 1, So it's really useful for a bunch of different stuff.
So if we go back to our example below, we
Yep.
go through the point by point what each of those lines are doing. Because this is a rudimentary program, but it is a program, and it's a program that, it's not a big step from this to actually creating a monthly savings calculator. And actually, if you've been on a bank's website and used any of their savings calculators or like mortgage repayment calculators, things like that, behind the scenes is basically something just doing this.
Yeah, you find that a lot of applications like that, for example, is essentially this in a kind of fancy jacket, right? It's got a nice looking interface, and it has cool features where you can use a slider to drag the value and so forth. But as a kind of the core of the algorithm is this. It takes, in this case, it takes two variables, adds them to this savings thing, and just prints it out. And that's at the core of it. That's what it does, right? So
I mean, if we go down to the 4i, so again, we know what 4i means. I is basically just a counter that says how many times have we iterated. In range basically means, you can think of that as meaning until. It doesn't really quite mean that, but you can think of it as thinking, keep doing this until this. And then for each line, it's doing that calculation. So it's adding to savings income minus expenses, which is whatever money we've got left over. And it is printing that out. Now, we went through print statements before and concatenation. So hopefully that's relatively clear what that's doing at that point. But it's basically printing the text, the string savings, plus it's concatenating that with I, which is the iteration. So we know that this is the month, the savings for this month, because the number of months is what we're iterating through. And then it's concatenating that against the value that we have stored in savings. And it's important to note, Ben, if we can just run this program again, and then do the 200, 100, and 12. So the important thing I think you need to walk away from this example with is that savings kind of is holding a state. We're adding to it every single time. Every single time, and that's what's coming out of on that. We're adding to it through iteration. Now, I don't think we need to go into that in much more detail, but if we go scroll back up to the top, Ben.
Yep.
We've got these two different types of loop. So if we just cut, just highlight and cut condition controlled iteration.
Yep.
And move that below the program. Just comment that out for now.
Okay, sure.
So that is our, and you know what, we might just share this simple program in the chat or something. It probably will go in the worksheets when that comes out. Let's stick with the example of a savings calculator. There's two ways that people tend to look at their savings. They want to say, right, how much am I going to save over this amount of time? Let's say, right, I want to buy a new guitar. And my guitar is going to cost me £1,000. So if we have another input, this is where we might use a while loop, and cost of guitar. And in the next line, let's do a variable for monthly savings.
No input or
Yeah, as an input, monthly savings.
okay, yeah, good. Monthly savings.
So now I have two pieces of information. I've got a value I want to get to. So I want to have enough money to buy my guitar. And I know how much I save each month. Now, this is the other way that we might look at our savings is we might actually just want to know how many months is it going to take me till I can afford my guitar. And this is where a while loop comes in. So Ben, do you want to take us through while loops?
Yeah, sure. So first off, let's make a variable. So similar to what we had here, we've got savings equals 0. So savings initially starts as 0, and like Chris said, we've got the cost of a guitar. So this might be, I don't know, 400, 500 or something, and a monthly savings. Say we can put 100 away. Now here, right, for loops, what we're doing is where we know how many times we want to run something, but in this case we don't know exactly how many times we need to save until we can get to that cost of guitar. Now you could do the manual calculation itself, but this is perfect for while loops, right? So remember we had for I in range and all this kind of stuff. In a while loop, it's called a while loop because it's while. Now while loops are very similar in syntax to an if. And remember we had an if. We had if something like a is more than 5, or in this case we have savings more than or equal to cost of guitar. Then do something. We could say print buy the guitar, buy the guitar, something. But what we want to do essentially is add to that savings variable while we still don't have enough money. So essentially, we want a condition here. We want to say while our savings is less than the cost of guitar. So this will be going up. This savings, as we go through each month and put money into our bank account, this will go to 100, and then 200, and then 300, and then finally, when we get to 400 or 500 or whatever price we put in, we can finally say
vastly underestimate how much my dream guitar is going to cost.
So, but yeah, as this is increasing, as we're putting money into it, right? What we do is we're just testing each time we put money in. We're essentially asking, has the savings actually exceeded the cost of the guitar? And if it has, then do something. But while the savings value, while the amount of money we have is less than the cost of guitar, then add to savings the amount we get per month. So this is put money in the account. You can kind of think of this as put money in the account, because this is your account, this is your savings, and you're just adding that amount that you get per month into the savings.
But there's something else that we need here. So we want to know how many months it's going to take us. So we actually need to, whereas with the for loop, we have the I variable, and we can just print that out. You might notice we haven't got an I variable with a while loop. So we actually need some way of maintaining a count for how many times that loop has gone through.
So let's do this now. So let's set count to 0. Now, we could call this I, we could call it count, we could call it iterator, we could call it whatever.
Months.
Yeah, months. So we can put months here, and then essentially for each month that we do, we can just add 1. So add 1 to month, right? So every month that we get money, right, what we're going to do is we're going to add 1 to this month variable. So this is kind of working how a for loop works. We start off at 0, we add 1, and we eventually do this, right? We do it each month, and then for each month we're going to say add the amount you get per month, monthly savings, to the savings variable. So this starts at 0, it's going to add 100, 200, 300, and so forth. And then what we'll do is we'll just print out, we'll take something very similar to this, right? Let's just copy this, and I'm going to change it slightly. So let's put months in here. So month number this, and what we'll do is we're going to print out savings. So it's very similar to what we had. We're going to say month number, and then this is going to be the month. So this will be 1, 2, 3, 4, all the way up to whatever. And then here we've got the actual value in our savings account, right? And finally, at the end of this, I'll just put a print statement saying "woo" by by the guitar.
Actually, what just there, just to demonstrate something, put there. It will take you months to buy guitar. And I'll explain why I want that specific. No, instead of your "woo" by the guitar.
Yes, okay, got you. It will take you months to buy this guitar.
Let's run the program.
Yeah. So, cost of the guitar, I'll let you decide this.
£2,725.
Jesus Christ. The savings.
I'm an academic, so about £20 a month.
Okay. So if we put this in, and as you can see, it will take us 137 months to buy this guitar, because finally, month 136. Actually, I think this is oh yeah, it's okay. Yeah, so on month 137, you can see that our money is actually 2,740, which is more than 2,725. So this, the first way we did it with the loop, we knew this number. We knew that it would be 137, because we knew in advance how many times we wanted to do something. In this case, we don't know exactly how many months it will take. In fact, that's why we're running the program, to find it out. So
now, the reason I wanted that, so if you see there's two print statements here. So you've got the print statement that's indented within the while loop, and the one that's after the while loop. Now, the one that's within the while loop is going to run every single time that loop runs round. However, because months and savings are declared, and we talked about declaring variables before, because they're declared outside that loop, those will be we're holding a state in those, we're holding information in those, and as we print them after the loop, this is why we get this specific information that we only run one time. So we can actually, if we comment out print month savings.
Yep.
We could add to that, it will take you months to buy this guitar, and you will have this much in savings. No, unindented.
Okay, yeah. And you will have plus str of savings in your savings.
Now, if you run this, you can see it's not going to print. Oh, sorry. Yeah. So sad. £20. We get the same results, but this time we've shrunk it down to one line. Now, there's one thing I would like to go. So I think we've covered while loops, and we're going to go through while loops and for loops in a bit, not more detail, but we're going to come from a slightly different angle when we write our first piece of proper software, which we're hoping is probably going to be our next episode, which can be after Christmas. But let's go back to these else ifs and show how we can actually turn this into quite a useful piece of software. So if we go up to the top, Ben.
Yep.
And we uncomment our first piece of code.
Yep.
And now let's have a new input.
Yep.
Right at the top. And we'll call it which calculator. And we're going to have an input that says press 1 for savings calculator.
Press 1 for yes, for savings. Oh, I yeah. So, what choice do you want, or something, or which?
Yeah.
Which? That's the word I was looking for. Which? So press 1 for savings calculator, and press 2 for guitar
purchase calculator.
This calculator, yeah. Okay.
So now we've got that which calculator variable, which we're going to put either a 1 or a 0. Now we can wrap this first piece of software in an if statement.
Yep.
So if which calculator equals 1, and we're going to indent all of that. So now it's wrapped within that if statement, and we'll have an else if. If that's equal to 2. And let's change the cost of guitar to cost of product.
Product, yeah. I'm guessing you want me to.
Yeah.
Okay, let's just quickly do this. So let's just take that out, and let's do that, and I'll just take this out as well. There we go.
Yeah. So now what we've got there, if we just go through that, so we've just combined the little bit of knowledge that we got from last week and the first bit of this episode, where we can run different parts of code based on the specific condition. And in this case, we've got a kind of a binary choice. We've got a 1 or a 2. And we're going to either run a savings calculator or we're going to run a purchase calculator. So if we run that piece of code.
Yep. So it asks us, press 1 for savings calculator, press 2 for purchase calculator. So if we do, I don't know, 1, then we get this thing. We get income. So if we put 200 and we put 100 in, and we say 12 months, we get our original program, right? You get, and this is because I typed in 1, right? Because I typed in 1, it got assigned to this variable which calculator, and then it came to here and it said, if which calculator is equals 1, then run this bit of code, right? Now, if we run this again, and instead of 1, we put in 2. Now we get the guitar, well, not the guitar calculator, I should say.
The product calculator.
Yeah. So say we put in, the cost of our, whatever it is 500, and we get, I don't know, £15 a month. Then it says, it'll take you 34 months to buy this product and you'll have 510 in your savings. So that's great, right? And essentially, to repeat what I said, because we pressed 1, not here, but last time, it ran this bit of code. But now we've typed in 2, right? So what's going to happen is it's going to come to this and say, is it 1? No, it's not. So it goes to this one and says, is it 2? And in this case, I have typed in 2. And this is what we get. It runs this bit of code that's highlighted here.
Now, where this gets really powerful is we could put all of this within a loop in itself.
Yeah. Yeah. So, I mean, should we put a while loop in there?
Yeah, while running equals true.
Running equals true.
But
let's put running equals to true, right?
Yeah.
And then all of this, chuck it in. And I suppose, right, we could add another option.
Press 3 to close program.
Yeah, press 3 to close program, right? To close program. So again, right, we talked about readability before, but this is where when you start writing actual programs, you can kind of see how now things are starting to look slightly unreadable, right? And this is where things like code folding can come in useful. So there's a little toggle here. I can click this and just hide the bits that I don't want to see, So again, we can do this thing. We can say if which calculator is equal to 3. Then we set running to false this time. And essentially what's going to happen is this is running while this variable called running is true. It's going to run everything here, right? And then it's going to get to here.
And you're going to have to do something that's upsetting me.
Okay.
You need to cut and paste that count controlled iteration comment to the right place.
Yes. Okay. Yeah. It was number 1, wasn't it? There we go. Okay, so let's just make it nice and spaced, I guess. So now we can start to see that indentation is becoming. We've got a block here, and this is we've got an if here, and inside this if is all this stuff, and then inside all of this there's a for loop, and this is where you start to consider things like readability. But anyway, let's run this and see what it does. So if we want to go to our savings calculator, let's do 200, 100, 12 months. And now, instead of exiting like it did before, it asks us again, which one do you want? So we can do the purchase calculator, and we can say the cost of the product is 500, and we get, I don't know, £18 this time. it'll say it'll take you 28 months instead. But
we can do, just to prove that we're not just running through the program in order, we can do one again.
Yeah. So which one we could put in? I don't know, 500. Expenses is 200, I guess. And let's put 14 months, right? And now again it asks us press 1, press 2, press 3. If we press 3, finally, there's nothing else. We can't do anything else. So 3 actually exits the program. So this is starting to look like an actual bit of software. I mean, so far we've just looked at small examples and we've done little calculators and so forth. But this is actually it can be a pretty useful program. You can imagine this running, and it might be used somewhere.
We could extend this with a whole bunch of different calculators. And we could use this as a proactive piece of software. I mean, like I say, we were talking about the kind of calculators you get on bank websites are relatively simple pieces of code doing just this. But I mean, quite, if you go back to not that long ago when a lot of software was console based, was command line based, this was essentially what was going on. And hopefully it's not hard to see how you could extend this into something really useful. So I think that's the conclusion. I think what we'll do, and by we I mean Ben, is we'll tidy up this piece of code, and we will include that in probably in the description of this video. And we are getting a website set up, which is quite exciting. So we'll make sure this example is there and available. Thank you again for tuning in to the Ben and Chris show. We've been getting loopy.
Yeah. But yeah, hopefully you guys enjoyed that. This stuff at the end, you can see now how we've gone away from just talking about the language, and now we're actually starting to write useful software. So yeah, thanks for coming along.
Brilliant. Cheers, everyone.